Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a undesic equation. The reason I call that undesic is because of the 11th power. Or is this a decic equation? Maybe something is going to cancel out. Anyways, you get the idea hopefully. We have z to the power 11 equals z, and we're going to solve for z. And I apologize if I did this problem before because I've done similar problems. That's just going to be a repeat, but let's see how they end up comparing. I'll be presenting two methods, even though one of the methods will be incomplete, and you'll see why. First method, we have z to the 11 equals z. What is the name of this channel? Quick quiz, A plus BI. So we're going to call z A plus BI. We're going to set it equal to that. And then, of course, we need to raise z to the 11th power, and that's supposed to equal z. By using the binomial theorem, you can go ahead and expand this. You're going to get 12 terms, starting with something like 11 choose 0, a to the 11, b to the power bi to the power 0, then 11 choose 1, a to the power 10, bi to the power 1, so on and so forth, and good luck with that. That's going to be a lot of work and a lot of struggle. And how do you solve that equation? That would be a good question. Anyways, that's the first method, which is going to end up incomplete. So let's go ahead and talk about the second method because it'll be more fun. So we have z to the power 11 equals z, and I just want to set z equal to r e to the I theta without making any assumptions. And then if I raise both sides to the 11th power, this should be r to the 11 times e to the power 11 I theta, or I times 11 theta, whatever. And then, of course, I want these two things to be equal. R to the 11th times e to the 11 I theta is supposed to equal r e to the I theta. In order for these to be equal, because these are complex numbers with modulus 1, the r's have to be equal, right? What does that mean? It means that r to the 11 equals r, which means r times r to the 10th minus 1 if you put r on the left, and factor, set it equal to 0, and solve for it. You're going to get three solutions. R equals 0, R equals 1, and R equals -1. And you get a -1 because 10 is even. Makes sense? R equals 0 implies z equals 0 because there's only one complex number with 0 modulus, and that is 0. Unique, right? R equals 1 means z can be written as e to the I theta, right? Because there's nothing in front of it, or you don't write it. And r equals -1 doesn't mean anything because modulus cannot be negative. It's a non-negative real number. Okay? So far so good. So since we end up with, if z does not equal 0, suppose z does not equal 0 because we already got that as a solution, then z will be e to the I theta. What is theta though? Do we know? No, we don't, but we'll find out. Okay. And so here's what we're going to do next. Z to the 11, we know that it's going to be e to the 11 I theta. We want this to equal z, so e to the I theta. If the bases are equal, so are the exponents. I theta cancel out, and we end up with 11 equals 1, right? No, that's not right. You shouldn't do that. You should not oversimplify things. We have to be careful. You know why? Because when you wrote e to the 11 I theta equals e to the I theta, that was actually correct. But you should not forget to multiply by 1. Wait a minute. By 1? Well, this is 1. E to the power 2 pi ni, right? This is the complex version of 1, or complexified version. So now, this is good because we basically are taking the periods into consideration, right? I mean, 11 times an angle is not going to be the same angle unless you consider the rotations. So here's what it is. 11 I theta equals I theta. By the way, we're going to add the exponents plus 2 pi and I. So what can I do here? I can simplify the i's, divide by I because I is not 0 as far as I know. We get 11 theta equals theta plus 2 pi n. Oh, by the way, I forgot to say it. N is an integer. Okay, Zahlen. Z for Zahlen. and put theta on the left hand side, you're going to get 10 theta equals 2 pi n, and divide both sides by 10 to get theta. Theta will be 2 pi n divided by 10, and 2 goes into 10 5 times, and this is going to be pi n over 5, or n pi over 5. In other words, we need to consider pi over 5, which is 36 degrees, and then look at multiples of 36 degrees, such as 36, 2 times 36, 3 times 36, and these are all in degrees, by the way. Sometimes I don't write the degree symbol, but it's understood, hopefully. And then 36 times 5 is just going to be 180 degrees. So how many multiples of these numbers are we going to use, though? That's going to be a good question. We kind of need to continue until we repeat. For example, if n is equal to 10, you're going to get 2 pi, which is the same as 0. Is that going to be a solution? Yes, right? And what about n equals 0? We didn't consider that. That's going to give you 0, which is going to be the same thing as 2 pi, by the way, or 360 degrees. I just couldn't remember what 2 pi is. Anyways, you get the idea. So how many solutions are we going to get? 10 solutions. How do we find them? Let's go ahead and see. So again, if n is equal to 0, then z is going to be, by the way, we call these e to the I theta, right? Or e to the I, what was it? E to the, I forgot. E to the I pi n over 5. Okay, great. So those are the solutions. If n is 0, then z is going to be 1. E to the power 0. You could also write this as cosine of 0 plus I sine of 0. And sine 0 is 0, so it'll be 1. Good. So far, so good. If n is equal to 1, though, then you're going to get something more interesting, of course. Z is going to be e to the power I pi over 5. But don't leave it at that, because, I mean, even though it's really compact, let's go and look at some numerical values, shall we? You're going to get z equals cosine of pi over 5 plus I times sine pi over 5. Now, what is cosine of pi over 5? I hope you know that, and I recently made some videos that touch upon that, but cosine of 36 degrees, which is the same thing as sine of 54 degrees, by the way. And for sine of 54 degrees, you can do lots of different things. You can use a pentagon, you can use double angles, so on and so forth, but I'm going to give it to you to keep a long story short. And this is basically going to be cosine pi over 5 is root 5 plus 1 over 4. And then the sine of pi over 5 is going to be the square root of 10 minus 2 root 5 all over 4. By the way, it's not as nice as this first one, but if you want to make the cosine 36 a little less nicer, you can write it as the square root of 6 plus 2 root 5 over 4. So it kind of looks like the second one, which is not necessary, by the way, but anyways, I did it. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.